Hello and welcome to Equations and Inequalities, where today we're going to look at the topic of quadratic simultaneous equations. So here we have a quadratic simultaneous equation where we have equation 1 and 2, and you can notice that we have x squared in it. That means that we have quadratic simultaneous equations, and so we cannot use elimination. We have to use only substitution for those kind of questions. So here, what we can do is that x could be equal to 3 negative 2y, to bring 2y to the other side to get our equation number 3 from equation 1. And what we can do is we can use our equation 2 to say that x squared is going to be 3 minus 2y squared, so that it will be 2 times, plus 3, replacing the x again, and y, and equals to 10. So now we're going to tidy this up. Now that we have expanded the brackets, we can now proceed with collecting the like terms. So here I got minus 6y squared and 4y squared. Here I got y's over here, and we got the numbers over here. So once we collected the like terms, we can move the 2y squared to the other side because we don't want it to be negative. So that will be 2y squared plus 3y plus 1 equals to 0. And now we can use one of the methods, factorization, quadratic formula, or completing the square, to solve the following. I am going to use factorization. That means that there will be 2 and 3, because 2 multiplied by 1 is 2, and the 3 on top, so that is 2 and 1. Now we are going to split here to get 2y squared plus 2y plus y plus 1. Now we're going to split like this, and now factorize them separately. So that will be y plus 1, that will be plus 1, and y plus 1. So 2y plus 1 and y plus 1 equal to 0, of course. And so we equal them both to 0. And what happens, we get two values of y, which is minus a half and negative 1. Now what happens is we plug in those two numbers of y into our equation 3 that we created from equation 1. And what happens, x is equal to 3 negative 2y. So x is equal to 3 negative 2 times negative 1, and x is equal to 3 negative 2 times negative a half, and we get 5 and 4. So x equals to 5 and x equals 4. So what we get is y equals to minus a half, y equals to minus 1, and x equals to 5, and x equals to 4. But what we want to do is to group them together. So basically, when we have y equals to minus a half, then we have 4, and when we have x is equal to 5, we have y equal to negative 1. So what we want to do is to write them like this, where you say y equals to minus a half, x is equal to 4, or y is equal to negative 1, and x equals to 5. So that is a better way of writing it, and that's how we do it. We just substitute the first equation into the second equation. Here we got an exam question number 4, where we have to solve the simultaneous equations, and here is an x squared, so that will be a quadratic simultaneous equation. And we can substitute any value, so that could be x or y. We have a choice, and I'm going to go with substituting y equals to 3 minus x. And I've done that because then I don't have to expand the x squared, which could take a lot of time. I'm just going to times it by minus 3y. So here will be x squared minus 3 and the y equals to 1, and x squared minus 9 plus 3x is equal to 1. So x squared plus 3x negative 10 equals to 0. And so we can factorize it. So we got negative 10 here and 3 here. So that will be 5, negative 2, and x plus 5, x minus 2. We make them both equal to 0, so that x is equal to negative 5, and x equals to 2. So now we have to find the y, so y equals to 3 minus x, and therefore y is equal to 3 negative negative 5, or y is equal to 3 negative 2, which is 8 and 1 respectively. And so when x is equal to negative 5, we have y value of 8, and we have y equals 1 when x equals to 2. So here are the solutions. Now this is the last question that we are going to do for the quadratic simultaneous equations. So we start with A. By eliminating y from the equations, we have to show that x squared minus 2x minus 11 is equal to 0. So we have to substitute the y equals 2 minus 4x into the second equation. So that's equation number 1 and equation number 2. So we have 1 into 2. So substituting the 1 into 2, we get 3x squared plus x and our y, which is 2 minus 4x plus 11 is equal to 0. So that means that 3x squared plus 2x minus 4x squared plus 11 will equal to 0. And so we have negative x squared plus 2x and plus 11 equal to 0. Now we have to put them to the other side, which becomes x squared minus 2x minus 11 is equal to 0. And so we have shown that x squared minus 2x minus 11 is equal to 0. Now, for the question B, hence or otherwise solve the simultaneous equations, giving your answers in the form of the third form, where a and b are integers. So here, we know that a and b are integers, and it is going to be in a third form, and so we cannot factorize it. We have to use our quadratic formula. So a equals to 1, b equals to negative 2, and c equals to minus 11. Actually, I changed my mind, and we will actually use completing the square. So after completing the square, I got x minus 1 to the power of 2 minus 12 equals to 0. And what I can do now is bring 12 to the other side, square root both sides. We can switch the root 12 to be 4 times 3, which is 2 root 3. So this is plus minus 2 root 3, because root 12 from chapter 1 is 4 times 3, and 4 root 3 is going to be 2 root 3. So that is it. And here we just add 1, so we get the following. X is equal to 1 plus 2 root 3, and we got x equals to 1 negative 2 root 3. Now we have to solve for y. So y is equal to 2 minus 4x, and therefore y can be 2 negative 4, 1 plus 2 root 3, which is going to be 2 minus 4 minus 8 root 3, which is negative 2 negative 8 root 3. So here will be y equals to negative 2 negative 8 root 3. And for the second y, we have 2 minus 4 and 1 negative 2 root 3. So that will be 2 negative 4 plus 8 root 3. So equals to negative 2 plus 8 root 3. And so the other value of y is going to be negative 2 plus 8 root 3. So it is either this set or it is either this set. And now you should be able to do quadratic simultaneous equations for exercise 3b.